Hello, my name is David Stevens. I'm the instructor on the module Propensity Score Methods, Models and Adjustment, and I'm going to give a quick introduction as to what the module is going to contain. So the key challenge that the module addresses is the capability of researchers to make causal conclusions from observational data. In many clinical and epidemiological settings, the central focus is trying to understand the effect of a treatment or exposure on outcome. That is, if the treatment is changed from, say, one type of treatment to another, what is the consequent effect on the outcome for the patient concerned? Now, if that treatment is experimentally assigned, that is, assigned by an intervention of the researcher, then causal questions can be answered, because it's understood that the intervention of the researcher has been achieved independently of all other confounding factors. And so in such studies we can genuinely get at cause-effect relationships. However, commonly we're faced with the analysis of observational data, that is, data that has been collected by observing a population without the intervention of the researcher to affect treatment or exposure. And therefore we have to entertain the possibility that treatment assignment is affected by confounding factors, that is, patient characteristics, environmental factors, and so on. And in such cases, because of the lack of an intervention by the researcher, on the surface it seems as if untangling the complex relationship between confounding factors, treatment, and outcome is so complicated that it prevents us being able to make causal statements. And what that means is the traditional tools that we would use in clinical and epidemiological studies, such as regression methods, are not sufficient to facilitate the inference that we're after. So what this module focuses on is the collection of methods that we have developed to facilitate the use of observational data to facilitate causal conclusions. So the module breaks down into 4 parts. First of all, I'm going to give a general introduction to the issues concerning confounding in observational studies. So a description involving some real examples, some of the elementary mathematical components that lead us to understand the issue of confounding in observational studies, and then try to focus on one specific aspect in the second part of the module, which is balance. So balance is the idea that within treatment groups, the representation of certain confounding factors is balanced across those groups. So of course, in an experimental study where treatment is, let's say, randomly assigned, balance is already present. But in observational studies, such balance is not present. And so what I'll do is talk about several elementary ways of introducing that balance to facilitate the causal conclusions that we're after. And this section will conclude with the introduction of the propensity score. And I'll introduce the propensity score from first principles and demonstrate how the propensity score is basically motivated by the need to manufacture balance in the observational study data. So having introduced the basic concept of the propensity score, I'll then go on to demonstrate how standard statistical tools such as regression or standardization or weighting methods can be adapted to utilize the propensity score in a rather straightforward way to facilitate the causal answers that we want to obtain from our observational data. So the final part of the module will concentrate on using those tools, those regression tools, those weighting tools, in a series of examples, practical examples. So I'll be demonstrating the use of these methods with R code and showing that really some quite sophisticated analysis can be done using really very elementary and well-known statistical procedures. So I hope this module will be useful for researchers in clinical and epidemiological settings. The module will be a mix of mathematical components. It'll contain a discussion of real examples, and it'll contain some R simulation studies, some practical examples drawn from my own research where I've used propensity score methods to try to make causal conclusions in different settings. The preparation for the course, I think that you need, really essentially an understanding of core statistical methods such as regression would be sufficient. Some knowledge of R would be useful, but hopefully the R code that I'll be able to present will be easy to understand, and then after the module, hopefully participants will be able to take that code away and modify it and use it to solve their own inference issues.